The next award is the OOPSLA Most Influential Paper Award, which will be given by Dick Gabriel, the program chair for OOPSLA, also 10 years ago.
The OOPSLA Most Influential Paper Award is given annually to the authors of the paper published in the OOPSLA held 10 years prior to that has had the most influence in the field. This year the award goes to the authors of X10, an object-oriented approach to non-uniform cluster computing. Those authors are Philippe Charles, Christopher Donawa, Kemal Ebcioglu, Grothoff, Allan Kielstra, Christoph von Praun, Vijay Saraswat, and Vivek Sarkar. The citation reads, this paper presents X10, an object-oriented programming language based on the Java language and extends to make parallel programming effective and convenient for high performance and high productivity programming of non-uniform cluster computing systems. That is, computing systems in which both processor resources and memory resources are distributed. X10 highlights the explicit unification of locality in the form of places, supports explicitly controlled distribution and parallel processing of arrays, and allows the use of either lock-free synchronization using atomic blocks or explicit barrier synchronization using a novel clock mechanism. Although variants of some of these mechanisms had been explored in other language designs, X10 brought modern programming facilities to the scientific computing community by synthesizing a particularly useful combination of facilities within the Java language framework. Of note is that 2005 was the first year that Onward papers appeared in the OOPSLA proceedings, and the X10 paper was an Onward paper. So is someone here from X10? Yes, of course.
So first of all, thank you very much to the program committee and the program chairs for this award. So this Onwards thing was actually a little bit interesting, so let me recount how this paper happened. So Vivek and I are from the old school, and that means if the deadline is 7 a.m., you start at 7 p.m. the previous night. So we hadn't figured out, I didn't want to write this paper, but Vivek was absolutely insistent that we must get a paper in the proceedings, so let's do it. So we compromised on Onwards. It looks like it might get into Onwards, it won't get into the main proceeding, so let's do it. So that's how this particular paper came to pass. As I said, old school, for the young folks here, please don't try this. So actually, just a personal word, I would like to acknowledge this is the first time actually that, after about 25, 30 years of work in this field, I've been able to persuade my wife to join me here. Vijay Saraswat, thank you so much for being so patient for all of these years and letting me work on this X10 system. Now, of course, one of the problems with recognition is that you've got to make a decision on who to recognize. And here the decision was made, well, this was a very straightforward setting. What papers were submitted, so the authors of the paper, naturally enough, get to be acknowledged. And that's how you see the guys in the middle. It so turns out that most of those guys have moved on and are working on other things. But the folks who really make the X10 system be what it is are the folks around that circle. And I'm really pleased that Igor Pishansky is here, and Mandana Vaziri, and anyone else from the X10 team who's here, please do stand up, because their contributions, particularly Igor's, was absolutely phenomenal in the design of the language, the implementation of the compiler, and so on and so forth. So thank you very much, Igor. In fact, I'm pretty sure the paper as we had it back in 2005, it talked about a system that we had implemented on top of JVMs. That was, it was a toy system. It was the first realization of these ideas. And the only reason that X10 is still around today, and in fact used in IBM products, and in fact has a whole bunch of stuff built on top of it, is because of the system that was built after that first paper was done. In fact, if I would look back at it, there are just a handful of ideas that I think we brought forward to the table. Some of them Dick has already mentioned in his analysis, in his citation for the paper. The core thing was, look, there are just a few ideas that you need. This is the so-called APGAS, the asynchronous partition global address space form. Just a few ideas you need to take any language, any sequential language, C, C++. Vivek and company have done Habanero afterwards based on X10 ideas in C, C++. Now, our team, the IBM X10 team, has these ideas realized in Java 8 through the APGAS API. Take a few core ideas, places, distribution, async, finish, and so on, and you can build a pretty reasonable programming model that is usable and clean. I think that was perhaps, from my point of view, the main contribution that we made, and then you've got to realize this down system. So overall, I think we had, over 100 people years of work that has gone into this, over this 10 plus years work. And to me, having sort of a creature of corporate research, this has been a most unusual project in that I've never been involved with a project in corporate research that has lasted over 10, 12 years. So of course, a lot of it was because there was some external funding available, but a lot of it was people like Michael Hyatt, who I hope is in this room, was a senior manager who in fact strongly supported the project through a succession of VPs who went through the system. So that's all I really have to say. There are a bunch of ideas. Of course, please look up the papers. There are now a fair bit written. And then also I want to acknowledge Jens Spansberg, who was in fact the thesis advisor of Christian Grothoff when he worked on this paper, and later Jens also used some of these ideas in his own work. So thank you very much, and I much appreciate it.